we want to do two things here. We want to find the inverse of f, and then we want to graph both functions on the same axis. So let's go ahead and find the inverse here. Remember, we switch x and y. So x equals root 3 plus 3y, and then we want to solve for y. First step is to get rid of the square root, so we're going to square both sides. And then we're just going to subtract 3. And then we're going to divide by 3. So I get, and I'm going to try to write this kind of like it was in standard form. So this is actually going to be, I'm going to write this as 1/3 x squared minus 1 equals y. So this is the inverse. So the f inverse of x is going to equal 1/3 x squared minus 1. And now I'm going to graph both functions here. Let's start by graphing this function right here. It would be more helpful to write it as 3x plus 3, and so we see right here, this is an A transformation, so remember we have to factor that out. So I actually have my A transformation is a horizontal compression of 1/3, and then I've gone left 1. So if we take my normal parent function, this is a square root, so that's that little graph that just kind of starts here and goes that way. So if I start at 0, 0, and I compress 0, I don't move. So if I go over 1, I'm going to start right here. This is my new starting point for my square root graph. The next point on my parent function is 1, 1. So I'm going to horizontally compress it by 1/3. So now I'm here at 1/3, and then I'm going to go left 1. So I'm going to be right back here at negative 2/3, 1. The next point on my parent function is 4, 2. If I compress 4 by 1/3, I get 4/3, which is a little bit bigger than 1. And then I'm going to go left 1. So I'm going to be right over here. This last point I'm going to do is going to end up being on a whole number, because when I go over to 9, I'm up at 3 on my parent function right here. Now I can horizontally compress 9 by 1/3. What is 1/3 of 9? That should put me onto 3. And then I'm going to go left 1. So this is the graph of f of x. And now I'm going to graph the inverse of it, which is what we have right here. So this has a vertical compression of 1/3, and it has gone down 1. And again, if you kind of compare these transformations, you can see that they're actually inverses of each other. Horizontally compressing by 1/3 is the opposite of vertically compressing by 1/3. Going left 1 and going down 1, you can see how they're related. So now I'm graphing this. Oh, and we actually needed to make sure we only included the domain for this function here. This, my original function here has a domain restriction. When I'm under the square root, I have to be positive to be able to graph on the real number system. So that means that this argument under my square root has to be greater than or equal to 0. So that means that 3 plus 3x has to be bigger than or equal to 0. Well, if you solve that, x has to be bigger than or equal to negative 1. So that means that when I come down here and do when I write this function right here, that I have to make sure that I include that domain restriction for down here. So we can see here that my x values, when I graph that function, have to be bigger than or equal to negative 1. I'm going to have to include that when I do this. This would be a parabola, but I don't want to graph the whole parabola. I just want to graph the part that matches this piece right here, which is just going to be the positive part. So this is the domain of my function, but the range of this function, you can see, would be 0 up to infinity. So the range is y is greater than or equal to 0 of the function. Remember, the domain and range of the function and the inverse flip. So the domain of this inverse needs to be x is greater than or equal to 0. And we should have included that in our definition here. So let's include that. X is greater than or equal to 0. And the range of this function is going to be y is greater than or equal to negative 1. So we're just flipping this domain and range, this x and y, with the x and y for my inverse. So I'm only graphing this function when x is greater than or equal to 0. So if I take my normal parabola, and I start at 0, 0, If I do a vertical compression, I don't go anywhere, but then I'm going to go down 1. The next point on my parabola is also this 1, 1 point. I'm going to vertically compress it, so I'm going to go down here, and then I'm going to go down 1. So you can see I'm doing the same thing vertically as I was doing horizontally in my function, because they're inverses, x and y flip. My next point of my normal parabola was 2, 4. I'm going to compress it, 2, 4. I'm going to compress it vertically by a third, so I go down to 4/3, which is a little bit bigger than 1, and then I'm going to go down 1, and then when I'm on my parabola, when I'm on 3, 9, I'm going to vertically compress it by a third, so I go down here to 3, and then I go down 1. Now I'm only graphing this side. We've already talked about that domain restriction there. So when you just graph this side, it looks like this. And this one is the graph of the inverse. So this one is the function, and this one is the inverse. And you can see that they are just reflected over this line y equals x. So you can check your inverses if you graph them. You can check them because they should be the reflection over the line y equals x. That's this line right here.